Let's read this question, which is a question on conic section. So the question is, find the equation of the tangent to the hyperbola x minus 5 squared over 16 plus y squared over 12 is equal to 1 at the point 7 comma 3. Excuse me. Okay. Now here, to find the equation of a tangent, equation of a line, this tangent is a line, we need to find the gradient of that line. Okay, so you can find the gradient of the line by finding the gradient function. That means you have to differentiate this with respect to x. Okay, so let me write like this. So let me write the equation. Equation is x minus 5 squared over 16 plus y squared over 12 is equal to 1. So this is the equation of a hyperbola. So I'm going to write now differentiating, DIFF is differentiating with respect to x. WRT stands for with respect to x. That means I'm going to differentiate each of this with respect to x. I'm going to use the derivative operator. So I'll write d by dx of x minus 5 squared over 16 plus d by dx of y squared over 12 is equal to d by dx of 1. Okay, so we are differentiating this with respect to x. So I can take say 1 over 16 out. So this is 1/16 of d by dx of x minus 5 squared. I can take the 1/12 out. So 1/12 of d by dx of, I'm writing more steps so that you understand, it is equal to d by dx of 1. In books, they directly give you the answer and you don't understand how they got it. Okay. Now here, when differentiating this function, you have to differentiate the inside first. Fortunately, the differentiation of the inside function is only 1. If you differentiate x, you get 1, and the differentiation of minus 5 is 0. So basically what you do is you treat this as a power function. So this is 1/16 times 1 is the differentiation of inside. I'll write the differentiation of inside. Then the outside function, treat it as a power function, times 2 times x minus 5 to the power 1. Okay, plus 1/12 times, now you're differentiating y squared with respect to x. So in other videos I've explained how to differentiate this. So this is called implicit differentiation. So differentiating y squared with respect to x, which is not possible. So basically we're using chain rule. So when you're differentiating y squared with respect to x, what you do is I don't have the time to go over implicit differentiation. Basically, you differentiate this, that is 2y, and then using chain rule differentiate y, so that is times dy by dx. If this is confusing, I would like you to go and watch my videos on implicit differentiation. And d by dx of 1, or the derivative of 1, is 0. So let us simplify this, make it tidier. Therefore, this is 1/8. So 1/8 times x minus 5 plus, this is 1/6 y, 1/6 y times dy by dx is equal to 0. Okay. Now here you can write this with respect in terms of dy by dx, but now at this step we can write, let me change color. So let me write that we got a point 7 comma 3. Okay, so we can substitute this point in this equation. Okay, now we can write like this. Now when x is 7, y is equal to 3. Okay, because the point is on the, this point is on the hyperbola. So you can substitute this in this equation. So this is 1/8 times 7 minus 5 plus 1/6 times 7. No, I have done 1/6 times 3. Okay, oops. 1/6 times 3 because y is not 7, y is 3. So this is y. So 1/6 times 3 times dy by dx is equal to 0. Okay, so this simplifies to 1/8 times 2 plus half times dy by dx is equal to 0. So this is 1/4 plus half times dy by dx is equal to 0. So taking away 1/4 from both sides, so half times dy by dx is negative 1/4. Okay, and now multiplying both sides by 2. So let me do that step. If you multiply this side by 2, you have to multiply this side by 2. So here what I did is I took away 1/4 from this side, so you have to take away 1/4 from this side. That's why I got this. So this 2 and this 2 gets cancelled, so dy by dx is nothing but negative half. Or basically what I was saying, that the gradient, therefore we can say the gradient of the tangent, gradient of tangent at 7 comma 3 is equal to negative half. Okay, therefore I can say equation of the tangent, therefore equation of the tangent, we know that we know now the gradient is negative half, so I can write the equation of the tangent would be y is equal to negative half x plus c. Okay, so again I can substitute x, let me change color now. Again I can substitute when x is 7, when x is 7, y is equal to 3. So I can again put this back into this equation, because this point is a common point on the hyperbola and the tangent. So I can say 3 is equal to negative half times 7 plus c. So 3 is equal to, this is negative 3.5 plus c. So if you add 3.5 to this side, you add 3.5 to this side. So c is nothing but 6.5. So this is equal to 13 over 2. So the equation of the tangent is y is equal to negative half x plus 13 over 2. So this is the equation of the tangent. I would like to do one more example of this type, which is this question. I would like you to look at this question and try to do it yourself. And once then you can listen to my next video, which is on this question, where the question is, you've got a curve defined by x is equal to 9 cos theta plus 2 and y is 9 sin theta. So you want to find the equation of the tangent to this curve at the point when theta is pi by 2. So this is a parametric equation, and you want to find again the equation of the tangent. See you in the next video.